Hello friends, subscribers and new viewers of this channel, and welcome to Machine Learning and Data Science tutorials. In this tutorial, we explain the basics of Pandas series. This tutorial is split into two parts. You're currently watching the first part, and in this part we explain how to construct Pandas series and how to perform very basic operations on Pandas series. In the second part of this tutorial, we explain how to perform more advanced operations on Pandas series. But before we start with explanations, we need to mention the following. A number of viewers of this channel are not familiar with Pandas series. Pandas series represent a building block of Pandas objects, data frames, and other data structures. Consequently, it's very important to properly understand how to construct Pandas series and how to perform different operations on them. Okay, let's start with explanations. The first step is to open your favorite Python editor. In my case, I'm using Anaconda and Spider, and consequently I will start Anaconda. I will click on Start and I will search for Anaconda Navigator and I will start it. If you don't have Anaconda installed on your system, don't worry. I created a separate video tutorial explaining how to install Anaconda and Spider on a Windows machine as well as on Linux Ubuntu machines. I will provide these links in the description below. Okay, I will close here. And over here we need to start Spider. But before we do that, it's very important to make sure that Pandas is installed on your system as well as numpy. To do that, click on the environments over here, then click on base or root environment, and then click on this green play button and click on Open Terminal. And we are currently in the based command prompt or the based environment of our Anaconda or Conda. And over here we will install numpy and we will install pandas. To install numpy, simply type pip install numpy. And this should install numpy, but most likely you already have it. To install pandas, type pip install pandas. And you can see in my case that all the requirements are satisfied. However, in your case, you might see the installation progress. Good. Close this terminal, go back to home and click on Spider, and this will launch the Spider editor. Once your Spider editor is opened, click over here to open a new script. And over here, I'm going to erase this part such that I start completely from scratch. The first step is to import the necessary libraries. First of all, we need to import numpy as np, and then we need to import pandas, and we import pandas as pd. Pandas series represent a one-dimensional labeled array that is based on numpy and the array. First, we will construct Pandas series by using numpy arrays. To do that, let's set the random seed such that the code is repeatable. We can do it like this. And let's construct a random numpy array. I will call my array as random array, and it's constructed like this: np.random.randn, and over here we need to provide the size of our random array. For example, let's construct an array with 15 elements. So let's test this code. Select the code, do the right click, and click over here, and over here let's type whos to see our workspace, and we can see over here that we have our random array. Good. To construct Pandas series, we simply need to call the function pd.series, and we need to provide as an input parameter our random array. So let's do that. And the output will be our Pandas series, and I will call this series as series 1. And that's it. So let's evaluate this and let's see what happens. Okay, over here, let's type series 1 and voila, here it is. The first column are the indices and the second column are values. So for example, let's see what is the value at the index 5. So I will type this series 1 and 5 over here. And let's see what the output will be. And here it is. We can see that the output is given over here, and that's precisely this value over here. Good. Next, let's try to retrieve several stored elements or values at the same time. We can do it like this. We type series 1, and then inside we will provide a list of indices. For example, I want to access or retrieve value stored at 1, at 6, and at 9. And if we type this, we should get the corresponding values. So let's double check that this is okay. 1, here is 1, 6, here is 6, and 9, and here is 9. Next, we can use the slicing operator, similarly to numpy arrays. For example, if I want to access all the values or all the elements stored from 0 to 5, I will simply type this 0 until 5. And let's see what will be the output. And here it is. Notice that the fifth index is actually the value stored at the fifth index is not included, and this is consistent with numpy array philosophy and the logic of accessing the entries. Often when working with series or when working with data frames in Pandas, it's useful to print first several entries or last several entries or values. So let's learn how to do that. The easiest approach to do that is to type series, and then you can type head over here, and this will print first 4 or first 5 values. Similarly, if you type series.tail, this will print the last 5 entries. Oops, here I made a mistake. It should be series 1, and here it is. Our series consists of an index and a sequence of values. So let's see the index. We can simply type series1.index over here to see all the indices. And we can see that it's a range index starting from 0, ending at 15 with a step of 1. Let's see all the values. So let's type series1.values. So let's see all the values. Here they are. And the result is a numpy array. Okay, when creating series out of arrays, we are not explicitly setting the index label values. In this case, Pandas will automatically assign sequential integer values starting from 0. However, when constructing a series, we can specify a non-default index values, and let's learn how to do that. To illustrate this, let's construct another series. I will call it series 2, and again I need to call the constructor pd series, and over here we will specify a list containing the values. So the values will be 2, 3, 2, 4, and 7. And over here we can specify the index list. Let's do that. Index, and let's use, for example, letters. For example, A, B, oops, let me now nicely write, C, D, let's see, now we have 4, we need another one, and E. Okay, so let's see this series now, and let's type series 2, and here it is. Now you can see that indices are letters and the values are actual numbers. Good. So let's try to retrieve some value on the basis of the letter index. So we can simply type series 2 and then we can say A, and the output should be 2. Let's verify this, and the output is actually 2. Then we can retrieve several values. Again, we need to pass a list, for example A, and then let's check C, and the last one E. And let's see the output. Here it is. Perfect. We can also access the value in this case by using the position. Let's learn how to do that. I will simply type series 2 and then I will type ILOC, and over here I will specify the position. For example, position 1 is entry 3, or better say value is equal to 3, etc. Now, we can get the size and shape of series by simply typing len and then series. This will return the length of the series, and we can see that our series has 5 rows or 5 values that are stored. Next, we can also get the shape, similarly to the numpy arrays, by typing series2.shape, and we see that the shape is 5, nothing. Next, we can get the unique values, so let's see this, series2.unique, and let's see what will be the output. Okay, so we have these unique values, 2, 3, 4, 7. Notice over here that the value 2 repeats itself twice. However, this function will only return the unique values. Next, let's get the value counts. We can do that by simply type series 2, and then over here we need to type value, and then we need to type counts. And let's see the output. Here it is. And we can see and analyze what's happening over here. The value 2 has the count of 2, the value 3 has the count of 1, the value 4 has the count of 1, and the value 7 has the count of 1. Good. Next, we can create series by using dictionaries. So let's create a dictionary, and I will call it dictionary 1, and the dictionary will look like this. The first name is John, and for example, its weight in kilograms is 81. Then I have the second name, for example, Michael. His weight is, for example, 100 kilograms. And then I have Anna, and her weight is, for example, 60 kilograms. So let's see our dictionary. Here it is. Oops, I made an error here. Here's our dictionary. Let's construct a series by using this dictionary. This is very easy. We will just type series 3, and then to the constructor of the series, we will provide this dictionary. And let's see the output. Okay, so if I type series 3, I will see that the actual values are 81, 100, and 60, and the keys or the indices are John, Michael, and Anna. For example, I can type something like this, series 3, and if I type John over here, let's see what I will get. I will get 81. And in this way, I can access the values corresponding to these indices or corresponding to these keys. Next, let's introduce missing values in our series. For that purpose, I will define a new object called new names, and I will use the previous names. That is, I will use John, then I will use Michael, then I will use Anna. However, here I will add a new name, my name, and I will add another name, Emily. Okay, so let's now evaluate this, and let's do this. I will define a new series, series number 4, and again I need to call the constructor of the series. As an input, I will provide dictionary 1. However, as an index, I will provide new names. So what I will do here, I'm going to re-index everything. And let's see what is the output and the effect of this. Now if I type series 4, I will get this. Notice over here that I introduce values that are NaN. That is, these are missing values. And notice over here that the indices are sorted in the more or less some manner. We have to see what is the manner. However, Alex is first, John is second, Anna is third. We can investigate that later on. Let's check for missing values. To do that, type series dot is null. And let's see what will be the output. And over here we can see that there is a missing value for Alex and Emily. And this is very good. Next, let's check if a value or a name or something similar is in our series. For example, we can do this. We can specify the name, for example, Patrick, in series 4. So let's see what the output will be. False. How about Alex? Is Alex in series 4? And true. Yes, this is correct. Next, we can also do list comprehensions on Pandas series. This is relatively straightforward. For example, you can just type A for A in series 4. And let's call this list, list 2. And let's see what the output will be. If you execute this, you will see that list 2 is now the list of values, NaN, and all the other values. And that's it. Okay, that's all for today, and see you in the second part of this tutorial.